Hello and welcome to my video, lesson 8.6 on the application of sinusoidal functions. So this is just a culmination of a whole bunch of different sinusoidal function questions. And although this is meant for 30-1, this really does fit for 30-2 as well, almost completely, other than some of the equation stuff later on. With that said, I actually did use some of the prompts from the 30-2 diploma in some of these questions and then changed the actual question portion of it for most of these. Okay, let's take a look here. So to begin with, we need to understand that this is the general form. These are the four different types of transformations that can occur and what those characteristics actually mean on a sinusoidal function. If you don't know what those are, you might want to go back to my previous videos and refresh yourself on that. Okay, so here's our first question. The height of a rider on a Ferris wheel can be modeled with the sinusoidal regression function there, where the height, h is the height above the ground in meters, t is the time in minutes. When the rider is at least 11.5 meters above the ground, you can see the rodeo grounds. During each rotation of the Ferris wheel, the length of time the rider can see the rodeo grounds to the nearest tenth of a minute is blank. There are multiple ways to solve this, but by far the best one is to do it graphically. So let me pull up my graphing calculator and then show you. All right, so here we have our graphing calculator, and so I'm going to talk through every step of the way, but what I'm going to suggest you do is you just plug it into your y equals position y1. So 6 sine 1.05 x, which is t, minus 1.57, end the bracket, plus 8. Okay, so this is our function. Now, if we want to make sure that we can see it all, we can just double check our window settings. And I know that my time is not going to go in reverse, so I'll go like that, and I will make my total 60 minutes. Yeah, that's probably more than enough. We might want to trim that down later. And then my y minimum, well, I'm not going to go into the ground. And what's my maximum? Well, the midline is 8, plus I go an extra 4 above that with these two numbers. So 14 is the highest, so I'm going to go with 15. I'm going to graph that, and you can see that I did see too much, i.e. in the x direction, it's too wide. So we're going to change that and make it 15 minutes, and then see if that's enough. Okay, pretty close. I'm going to change it to 10 minutes. I think that'll be perfect. Okay, good enough. So hopefully you can understand how I came up with that. The only real hard one was to find the y maximum, and that's with the 6 plus 8 is 14, and I just did one bigger than that. Okay, so it asks when the rider is 11.5 meters above the ground. So I would make my y2 11.5 and then graph it, and you can see this is the height, the red line is the height where the rider is 11.5 meters above the ground. So we need to know how long is the rider above the ground. So if we can find the value at this point here and this point here, then it will all be great. So we're going to get the intersect of this one, enter, 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 and that'll be 3.89 nearest tenth. Yeah, let's do one extra decimal just in case, minutes. Okay, but that's not the total answer. What we need to do is go back to this one, enter, 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 and we get minus 2.088 minutes. And so if we find the difference between the two, that's like the distance on the graph between those 2 points, then we are golden. So I'll give you a little bit of a trick. So 3.894 for the first one minus, well, x is what the graph reported the 2.088 as. So if I put in minus x, that x is the 2.088. we can press enter and get a number. And just for your curiosity, that is the same number we would get otherwise, except that the x actually keeps all of the digits of precision. Okay, so we get 1.8, and it just rounds to that, minutes as our final answer. Okay, let's keep going to the next one here. This one's also answered graphically. So what we're going to do is just create a new graph. So 4 sine x plus 1.57 plus 6. Whoops, should have the plus 6 on the outside. Oh, and I totally forgot the value beside the x. So second function, insert 0.15. If you do second function and then I and S, the insert button here, it's by delete. You can put stuff in without deleting the values. Okay, so this is great. We can now graph this. Now we'll see how much room we have. So that's pretty good, but we want to make it just a little bit bigger. So what I'm going to do is, t is in hours. So I want to see a whole day. So I'm going to go 24 hours. And you can see a full day there. Okay, I don't know, by the way, if this question is going to make any sense because this question is from a different prompt, but we'll see about that. Determine the maximum and minimum depths of the water. We're going to see in a moment if that number makes any sense. I think it will, actually. So to find the maximum, we use the maximum feature of the second function calc menu. So the maximum is 12.32. This is in meters, right? Yeah, meters. Okay, and then if we want to find the minimum, we do the same thing, except we do the minimum. And we find that question will not make sense. Okay, and we find 6.16 meters, which means that this question doesn't make any sense, and we'll maybe change it to 7.5, just so we have a number that makes sense in this question. Okay, what is the period of the tide? Well, what we need to do is from peak to peak, or trough to trough. And since we already have the trough, and I can see the other trough, this is the one time. What I need to do is I need to find the other trough time. Oh, this is not minutes, this is hours. Oh man, I screwed up. No, part A is easier than that. Part A is just maximum and minimum depths. These values that I wrote down earlier, those are the time. Maximum, minimum depths, that is just going to be our midline minus, and speaking of, then this is perfectly fine. Our midline minus the amplitude, so our minimum is 2, and our maximum is the midline plus the amplitude, so 10. So all it is 6 plus 4 and 6 minus 4 for those two answers. Okay, my fault. Okay, let's go ahead and keep working on part B. So we're going to go over to the other minimum point. And we need to have a left bound. So enter. Then we're going to have a right bound, enter, and then guess, enter. And so we get 18.48 hours. So if we subtract those two values, what do we get? So again, I can use my little x trick. So I can go x minus, because that's the most recent one I used, 6.16. And I get 12.3 hours as my period. Now, that's one way of doing it, but we can also simply look at the value here to figure out the period if we wanted. The period is 2 pi over b, but this is the b value, yes, but we would have to just make sure that if we're finding the phase shift, that we take out the b value when we find this c phase shift value. So just keep that in mind. But if we're looking for the period, going like this will also give us the number. So let's go ahead and show what that would look like. And we should get the same number. And we do. We do. Still 12.3 hours. Okay, so just by looking at the equation, we can actually figure out the answer without actually doing any graphing. But you can also use your graphing to solve for this. Even the part A, when we get the minimum, right, it's going to tell us our y value, and our y value minimum is 2, right? And that matches part A. Okay, so you could use the graphing calculator or you can look at the equation. Let's keep going. Part C, graph for 2 cycles starting at t0. Well, if we need to get 2 cycles, we need to make sure our window settings can show the 12.3 doubled, because that's 1 cycle, so we need to double that. So we're just going to make it 25, and that could be a suitable window. So, 24.6, right? But I'll just do 25. And if we're trying to write the suitable window, then we want to show it the way that the diploma asks us to. So 0 to 25, and with 1 as our scale. So that's the 0, 25, 1. And then if you do the same thing in the y direction, we went from 0 to 15 and 1. I think that's, yeah. Do we want to do it any differently? Well, since we know the minimum and maximum, actually we're going to change our maximum to just 12. It doesn't really matter, but then it shows it just a little bit more clearly. So we'll go with 12. Okay, let's keep going. Part D, find the depth of the water at 7 hours. So what we're going to do is second function calc value, and you can type in 7, and you can do that and it'll work great. Or you can type in h equals 4 sine 0.51 times the 7 hours plus 1.57 plus 6. And this will also get you the same number. So it would be 2.36 meters. Okay, and so if we're asking the boat to have a minimum of 3.5 meters of water in order to launch safely, all we do is we put that in for our y2. And we consider how many hours per cycle the boat can launch safely. So there's multiple ways to do this, but if we take this value minus this value, that's for one whole cycle between the troughs, between the valleys or the bottoms, the minimums. So the two parts where it gets above that. So second function calc, intersect, enter, 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 and I get 16.725 hours. And then what I'm going to do is the same thing again, but I'm going to do it for the other side. Enter, 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 and I get 7.9177 dot, dot, dot. And so what we need to do is subtract these two. So 16.725 minus x, and I get 8.807 hours. So this is how many hours during one cycle that we can launch the boat safely. Okay, just 2 more questions that we're going to do, and then we'll be finished this video. Here, now we're going to try to create a graph based off of, well, create an equation based off of a situation, and here's a graph. So in this situation, it talks about a bicycle wheel and a noisemaker. This is the noisemaker. And as the child is biking, as the wheel is rotating, that noisemaker is going up and down, up and down, and up and down. So the radius of the bike tire is 20. So that tells us to the center from here to here is 20, which is helpful because that tells us the midline. Okay. Also, it kind of looks like this is in the center going up. We'll have to double check if it's in the perfect center, but it looks like it. We'll think about that more in a moment, but for now, we'll keep it as a sine function. We'll leave a little bit of space, and it's plus 20. Okay, so that midline is the plus 20. Then we can think, okay, what is the amplitude? How much is the distance from there to there? Well, it is 8, probably better this way. It is 8 centimeters here, as it states right below. So this is the amplitude there. Okay, if we continue on, we need to figure out the phase shift. Now, it's starting in the middle, going up. So I'm going to say that the phase shift is 0. So we can actually get rid of all that and just say x. And then last but not least, we need to figure out the period. And you know what? It doesn't say enough information, but I'm going to say this is 0. This is 5 seconds over here. No, I'm going to make this 5 seconds. Right here. Okay, and so if that is 5 seconds, how can we solve this? Well, this, if you follow along from here to here, is 1 full period. But this is a partial period. Okay, right? So this is half a period. And so those are 2 halves that make a whole. These are quarter periods. And so where I said the 5 was actually 3/4 of a period. So 5 is 3/4, 3/4 of a period. So if we want to find the actual period, we'd go 5 times 4 over 3. So we're just getting the t by itself. And so it ends up being 20 over 3. Now that's the period. But we still need to find the b value. So it's 2 pi over b. So if we move that over, b goes over here, and we get 6. Well, actually, we're going to go 3 pi over 10, simplify it. And so that's going to be our answer here. Okay, so it did require me to make up a number, but the process makes hopefully some sense. Okay, one last question. We're going to try to solve this one again, creating the equation without the use of the calculator there. The London Eye is an observation wheel. So you go onto it and it goes really, really high with a radius of 68 meters. Okay. The ride consists of 1 complete revolution, which takes 30 minutes and begins on a platform 2 meters above the ground. So it tells you all of this information, which is quite a bit. It also tells you that the radius of it from here to here is 68. Okay, and then we need to create an equation. Now, if that's 68, the midline is not 68, it's 68 plus the 2 that was here. So the midline is actually going to be 70. And I'm going to try to get the smallest possible phase shift. So To do that, I'm going to actually have a negative cos, because it's starting at the bottom going up. And so I'm going to go plus 70 like this. Okay, so it looks like it's starting at the bottom going up, and so cos normally starts at the top coming down. So if I do a negative, it just flips that. Okay, so we have this expression here, which is fantastic. But we need to figure out now a few more details, which is the the amplitude. So that's from here to here, and that'll be the 68 from before, so that's not too bad. And we need to figure out the phase shift. Now, if this is actually the bottom coming up, then we're actually done with the phase shift. So again, we got a little bit lucky there. And then last but not least, we're going to find the period. So from here to here is one full cycle. So that's 30 is one full period. So 2 pi over b. And so we need to just solve for b. So it's 2 pi over 30. And so we get pi over 15 as our b value. Whoops. All right, so I hope you can see that from all of these different examples that we showed, we can have questions that don't have graphs at all, and you can be given an equation to find like different details about the graph or about the situation, or we could be given a situation and a graph and be asked to find the equation, or there could be some combination thereof. So you could be given the details and be asked to find the graph. And then obviously if it's a written response, they could also ask you to graph based off the situation. So I hope that this video helped you better understand the application of sinusoidal functions, and good luck.